Hello, so today I'm going to be talking to you a little bit about the Galápagos Islands. Now the Galápagos Islands are beautiful. They have beautiful beaches. They have amazing wildlife. They're a place that I want to be right now. The Galapagos is one of the it's warm, it's beautiful, and it's located off in the Pacific Ocean off the coast of South America. Now, the Galapagos is very interesting because it was not formed because of plate collisions or anything like that, which you would expect seeing that it's in the middle of the ocean and very, very far off the coast of South America. And so it's interesting how these islands, all these islands, little islands that are all over the place in this one area, are formed. And why are they formed and what's going on there? Well, let me tell you a little bit about that. So to start out, to get a little heads up, I'm going to tell you a little bit about the actual structure of the Earth. And so this might look confusing, so you don't have to look at that right now. But to start out, we have the inner core, which is right here. Now, if we think of it as the Earth in a circle or a sphere, it would start out here, and this is the inner core. And so the inner core, I don't know if you can see that, but I wrote inner as in inner core. So the inner core is very hard and it's super, super hot. So it's this dense ball, and it's made up of mainly nickel and iron, along with many other elements, but it's very, very hot. And then outside of that, we have the outer core. And so the outer core is also very, very hot. Now both of these are about 9,000 degrees, 9,932 to be exact, which is crazy hot, like crazy. So then we have the outer core, and the outer core is actually more liquid, so it's not solid like the inner core. And that is because of this radioactive decay that is going on inside of the outer core. And so this is the radioactive decay equation, which we don't really need to worry about, but I just thought it'd be interesting to write that down. So because of this radioactive decay, it's causing movement, and it's causing heat, and so that's why the inner core is not solid, that is why the outer core is not solid like the inner core, because it's moving and it has more going on inside of it. So then above that, if we're looking back at this model, we don't need that anymore. We're looking back at this model, we have the asthenosphere. Now the asthenosphere, I know in this model, it looks crazy because a lot of stuff is going on inside of this asthenosphere. Now the asthenosphere is made up of this magma or molten rock. It's kind of slushy-like, it's thick, but it's also kind of liquid. And so it's, all, again, super, super hot. But then above that, we have the lithosphere, the lithospheric plates, or the oceanic crust. They're kind of combined, they're kind of like one on top of each other, but they kind of make up this one crust, and so, or this one plate. And so these plates actually move. And we'll talk about a little bit more about how these plates move in a little bit. But to finish the structure of the Earth, we have the lithosphere or the oceanic crust, and then above that we have the ocean, and then we have where we are, our air, our land. So going back to how these plates move. So the Galapagos is actually located on the Nazca plate. So if this is the Nazca plate, this plate is moving towards the South American plate. Now, how is this plate moving? Well, the plate moves mainly because of these things called convection currents. So convection currents are these currents inside of the asthenosphere. And it's this way of movement that is, for example, in this case, they're all going this way. So they're moving around this way. This one's moving this way. They're all kind of moving this way, which is causing this plate to then move that way as well. Now, the actual asthenosphere doesn't move. It doesn't move by itself. Just the convection currents are moving, but these convection currents are causing the plate on top of it to then move. And so this lithosphere, or the oceanic crust, this plate is moving towards the South American plate. Now, the South American plate is a continental plate, meaning it has the oceanic crust, but then it has continental crust on top of it. So above the plate, the South American plate, isn't ocean, it's actually land. And so because of that, it's causing this collision, this convergent, and it's causing one to go underneath the other, which can cause earthquakes and tsunamis. Now, this isn't something that happens often, okay? These plates move about 5 centimeters per year, or about the way that your fingernail grows. So as fast as your fingernail grows, which is not fast. So it's not like, these are moving really fast. They're very, very slow moving. And so if we're going back to the Galápagos Islands, let's think about the asthenosphere. So inside of the asthenosphere, we have these convection currents, which we talked about, and then we have this oceanic plate. However, that doesn't connect to the Galápagos. That's not why the Galápagos is formed. The Galápagos is formed not because of plate movement, but because of something called the mantle plume, or a hotspot. Now, a hotspot is an area inside of the asthenosphere that is super, super hotspot, and it's this like one area. It's about 100 miles wide, so it's very, very big. And it's this one area. It doesn't move. It doesn't have convection currents in it, but it's just super, super, like, extra hot magma, and more stuff inside it that's just extremely hot. And so what can happen because of this mantle plume is that every million years, it doesn't happen often, but this mantle plume will explode. And so it goes through the oceanic crust, and then typically through the ocean, and then it causes this island, which we're looking at right here, this island to be formed. And so because of that, this magma comes flying up, and then it cools into this rock, and then it causes this land to then be formed. As you know, the Galápagos isn't just one big island. It's multiple little islands that are all like separated, and they're usually pretty small. Some are larger actually, but they're all different, and they're all not connected as one island, because as this lithospheric plate moves, or as the Nazca plate moves, this mantle plume doesn't, and so it stays there, and then so millions and millions of years go by, and then this mantle plume erupts. So at one point, this island that we're looking at right here was over here. And then this erupted, it causes the island, and then millions and millions of years went by as this plate moved and moved and moved, and then it erupted in a new spot, this spot in this case. Then it moved and moved and moved and moved, and it erupted and caused this new island to be formed. And so if we're thinking about how this happens, and how that relates to the Galápagos now. So currently, the area over this mantle plume are the islands of Fernanda and the island of Isabella. Now, these two islands they don't know exactly whether it's right on top of it. This hotspot, again, is very large, so it could be near it. And so that is why these islands have these active volcanoes, because they're super, super hotspot underneath it, so they can erupt. And so this eruption will again cause a volcano. And so currently, island Isabella has Fernanda has one active volcano on it, and island Isabella is much larger, and it has 6 active volcanoes on it. And so as this plate moves, it'll cause this volcano, these eruptions, to eventually become extinct once they get, far enough away from this hotspot. But that'll be in years. And so if we're looking at these islands over here, these islands are most likely have extinct volcanoes on them. So the volcanoes were once over this hotspot and were erupting. However, now they are not. Now, if you look at the map, which I don't have right in front of me, but you can notice that a lot of the newer Galápagos Islands are located in the northwestern area, because this hotspot is in the northwestern area of the Galápagos. And so as this plate moves, these islands that are older are more in the southeastern area of the Galápagos. And so because of that, it causes these newer islands to be located in one area, whereas if you go farther to the southeastern area, they become older and they become extinct mainly. And so that is a little bit about the Galapagos, how it was formed due to these crazy hotspots, along with how some of this plate movement happens and what is going on there. So that is a little bit about the Galapagos Islands, how it was formed, a little bit about some plate movements, some continental, oceanic, convergence, everything like that. I hope you enjoyed this video, and I hope you learned a little bit about the beautiful islands we call the Galapagos. And so down here, I have some vocab that I talked about, and in case you didn't know anything, I know I said a lot of crazy words in this, and I hope I explained some of them, but just to go over some, we have the lithospheric plates, which again we talked about, or the oceanic crust. They're kind of combined, and they're that one layer that is actually moving and can cause convergent things when two different lithospheric plates crash into each other. They can cause divergent plate movement, which is when these two plates are getting pulled away from each other, and they can also cause transform plate movement, which is when the two lithospheric plates are moving like this. And so different things can happen due to different things that are happening, such as divergent boundaries could cause a rift. Convergent boundaries, it kind of depends, because it could be continental oceanic, which can cause one thing, such as tsunamis, or like we said, earthquakes, something like that. And then there's continental, which can cause like these mountains to be formed. And then there's oceanic, which can cause volcanoes. We then have the outer core, we then are going back here, and then we talked about the anthosphere, which is again where a lot happens, the convection currents, the hotspot, which cause the Galapagos Islands to be the Galapagos Islands. We then have the oceanic plate, which is this plate. It's also the lithospheric plate, which is that one area that is moving, and then over the oceanic plate we have the ocean. We then talked about the convection currents, which are the thing that is actually causing these plates to move the way that they're moving. So for example, like I said before, these convection currents are moving this way, which causes this plate to also move that way. We then talked about volcanoes, which are the eruptions that are happening on Island Isabella and Island Fernanda. We talked about magma, which is what the anthosphere is mainly made up of, this molten rock along with some liquid, and it causes this slushy magma. And we then talked about the mantle plume, or the hotspot, which again is being heated, and super hot, causing these Galapagos Islands to form when this mantle plume explodes. We talked about the inner core and the outer core, the inner core being that super dense ball in the center of our Earth, and then the outer core being the liquid, very, again, super hot area of outside of the inner core that is radioactively decaying over time. And last, we talked about the radioactive decay, which is happening in the outer core, causing this movement and this heat to be produced.